So I've been thinking a lot about state management in an Angular application, and recently I've been very attracted to the idea of creating some sort of abstraction that completely encapsulates the very notion of state management, so that choices like Redux or NgRx can be completely hidden away from the view of the application. I never liked the idea of this being this pervasive decision that everybody has to buy into. And what I'm choosing to call my abstraction here is a runtime. It's very similar to several other things that I've looked at in the last couple of posts. And this is going to be now my first experiment of taking that runtime thought and trying to apply it to an actual Angular application. And as an experiment, I've created a Santa's Christmas list here, and you can see I have a list of nice and naughty people, and I can go ahead and add people like Kim and John and Stephen and Jeff. And here you can see that the number of people on the list is increasing. I can delete people here, and you'll see that that also is changing. Here I can come over and add more people like Seema and Pam and Brian and Andrew. And again, the number here is going to change. And then as we tab back and forth between the two lists, the people in the list is changing. And of course I can come and I can delete people as well. You'll notice that I'm also reflecting the list in the URL. I'm not using a routing system. I'm just looking at the window.location.hash for the sake of this demo. Now what you'll also notice is that I can refresh the page, and you might not even actually see that that happened. I can refresh the page here, and you can see that I'm continuing to have the names persisted. And in order to do that, I'm actually using local storage, and we'll look at that because that integrates with where the separation of concerns is. So let's take a quick look at the code. So I don't want to jump into the runtime right away. Let's look at the app component because this is the view, and the whole point of this experiment is to completely encapsulate all of the state management decisions inside the runtime so that the view doesn't actually have to know about them. So what you'll see is that the dependency injection here, the only thing I'm injecting is the Santa runtime. That's really the only thing that this particular view has to know about, and it's going to reach into the Santa runtime and it's going to get a variety of RxJS streams for selected list type, people, nice count, and naughty count. And you can see that these are really the 4 data points that I have in my view, right? If we jump back here, we have the selected list type, the nice count, the naughty count, and then the list of actual people. Now if we look at the innards of this app component, you can see that it does very, very little. It does synchronize the location with the selected list, but other than that, it's really just a proxy to the runtime. So it doesn't have any of the business logic, it doesn't have any of the state management choices. It's just taking the interactions from the user, piping them into the runtime, and then using the RxJS streams to bind to the view. So let's take a quick look at the view. Inside the view, you'll see that I am using my RxJS streams here from the runtime, and I'm using the async pipe operator to essentially bind to the subscription of these streams and then render them inside the template. So I have for selected list, I have nice count, naughty count, I have my people, and then I have my people again over here. Now, I don't love this. I know that everybody uses the async pipe. It just feels kind of janky to me. I hate the fact that I have to bind to this twice. There is a way to do it where I can do like an ngIf here and then save it as a local template variable for the view. And but then that it just gets weird to me. I don't love it. What I'd rather have is these be actual static values that I then update within the app component. But that's all part of the experiment and trying to find the methodology that works right for me. But overall, what we can see is that the app component logic and the app component view are pretty straightforward. There's really no complex logic here. There's really actually no logic at all. The only logic that I have is around processing the location synchronization and processing the intake form. Now you will see that I am using the local component state to manage the intake form. I'm not using that as part of the runtime because the runtime doesn't care that I have a form for users. The runtime only cares that I add a particular user. So how I collect that pending data before piping it to the runtime, that to me feels like a view responsibility. That doesn't feel like something I actually want to maintain in my runtime. So now that we said that, let's take a quick look at the runtime. So the runtime is more or less a wrapper around this store object. And the store object, I've looked at it in a previous post, is essentially a glorified RxJS behavior subject, which allows me to pipe values into it and then get the current value out of it. What you'll see is, in the same way that the app component was essentially a thin wrapper to the Santa runtime, the Santa runtime is basically a thin wrapper to the store. And in here is where I can organize all of my asynchronous control flow, my more complex business logic, calling out to other data services. In this case, I don't have any other data services, but this is where I would do that. So for example, when the app component asks to add a person, what you can see is I'm creating that person object. I'm getting the current state. I'm checking to see which selected list is in play so that I know if I'm adding to the nice list or the naughty list. And then I go ahead and I patch the current state with either a nice people or a naughty people. And they're all going to be like this. So for example, when I get the, what's another one? If I remove a person. If I remove a person, it's the same kind of concept. I get the current state snapshot. I create a filter for removing the person with the given ID. And then I just patch the state with the updated nice people and naughty people. I'm changing both lists at the same time just to keep the logic simple, even though I know that only one of these should actually be adjusted. But again, just trying to keep it simple. Selects list, so choosing the nice list or the naughty list. Again, I'm just patching the current state. So as you can see, the runtime is really a proxy to the store with the business logic mixed in. And again, I don't have any calls to external APIs like a backend database, but this is where I would want to do that kind of interaction and coordinate it with changes to the store itself. Things like the get list and get people and get nice count, you can see that these are all just RxJS streams. They all essentially get that store, subscribe to it in some way, or create some sort of mapping to it, and then return that data. Now, as I was saying earlier, when I looked at the app component template, I don't love that all of the access to the data is done via streams. What I'd really like is for there to be both stream and snapshot access to the data. But at the same time, I don't want to expose the underlying store, because if I expose the underlying store, I let that implementation details of the store leak out. Right? I might have data in the store organized in such a way and normalized in such a way that I don't want the view components to have to know about or have to cope with. So really what I would want to do is create some sort of methods that expose kind of selector snapshot data and then selector streams as well. And I think one of those can just feed off the other. So that's something I'll look at in another experiment. But another thing that you'll notice here is that one of the concepts of the runtime, at least for me, was that it forces the runtime to decide whether or not and how it wants to persist data. So as opposed to having a single state tree where I persist the entire state tree or load the entire state tree into my current application, each runtime within the application has to make that decision for itself, which allows some runtimes to decide not to persist all of their data, either because maybe it's too voluminous, I can't remember how to pronounce it, or maybe it's sensitive data, something that we don't want to store in a particular state or in a particular local cache. In this case, I'm injecting what I'm calling the app storage service, and the app storage service is essentially a thin wrapper to the local storage API. And here you'll see that I'm using the app storage to register an unload callback, such that when the app is about to unload, I can go ahead and I can save this data to my local storage, which is why, jumping back to the application here, when I refresh, I get to keep that data, right? Because I've persisted to the local storage, and then when I load the application, I'm rehydrating the current runtime state from the local storage. And if we jump over into the app storage service, I can show you that again, it's just a thin wrapper around the local storage API and the window before unload event. So essentially the load data here, again, it's just a wrapper, a safe wrapper around local storage, because we know things like we'd run out of local storage, or if say you're in Safari private browsing mode, there is no local storage API, right? So we have to be careful about how we deal with that. Saving data, also just a local storage call. registering that unload callback, right, which is what I'm doing at the top of my runtime. I'm injecting that app storage and I'm registering a callback. That callback just gets pushed onto this collection. And then you'll see here that when I handle the unload for the browser, all I do is loop over that callback and invoke each of them, right? So what is the Santa runtime unload callback doing, the save to storage? If we jump down here, you can see that turnarounding and asking the app storage just to save a current snapshot of the underlying store. So there's a lot there, but again, mostly the point of this experiment was to see how we can use the runtime abstraction to completely encapsulate the choice and methodologies in the state management. And we can see that in the component here, there is no understanding of state, right? There is no understanding of RxJS versus NgRx. There's no understanding of whether or not data is persisted to the local storage, how it's being hydrated or serialized or deserialized or what have you. The app component or the view components in general simply use the various runtimes to bind to data that they need for the view and then to push data back into the runtime in response to user interactions. And that part of it I really like. What I don't love, again, is the fact that everything is a stream. I love the idea of the reactive programming model. I love the idea of streams being able to invoke subscribers only when their data is updated, but I don't love the idea that I don't also have snapshot access or current access to the underlying state in a way that doesn't allow details to be leaked out, implementation details. So that's something that I'll look at in a subsequent exploration, but for now, I like the direction this is going in, and yeah, stay tuned, I guess, for more adventure.